In this video, we'll be looking at properties of isosceles and equilateral triangles. To start off, we'll identify the parts of an isosceles triangle. So for an isosceles triangle, the angle formed by the two congruent sides is called the vertex. And then the other two angles are both referred to as base angles. Reminder that an isosceles triangle is a triangle that has two congruent sides. The isosceles triangle theorem states that if two sides of a triangle are congruent, then the base angles are congruent. So in this case, angle B is the vertex. It's the angle formed by the two congruent sides. And so then we would know that angle A is congruent to angle C. Here's an example of applying the theorem. So we're asked to find x and y. And if you look right here, here's the theorem. So we've got two sides of a triangle that are congruent. And so then those base angles, right there, we would know would be congruent. So x would also be 68 degrees. And then to find y, I can say we know that the sum of the degrees in the triangle has to be 180. So if I take the two angles I know, 68 and 68, that gives me 136. And then 180 minus 136 gives me 44 degrees. Here's another example. Again, we know we have an isosceles triangle because of the sides here that are marked as being congruent. So then those base angles will be equal to each other. So I know that x is going to be equal to y. Since we have the vertex, I can take 180 degrees minus 106, and that gives us 74. So that 74 degrees has to be split up evenly among the two angles that we know are the same. So if I take 74 and divide it by 2, that gives me 37 degrees. So x is 37, and y is also 37. We can take this one step further and add algebraic expressions to either our angles or our sides. So in this case, here we have that the base angles are congruent, and so that would tell me then that these two sides are the congruent sides. And so if the sides are congruent, then I can set them equal to each other and solve. So here, this is just a multi-step equation. I'm going to subtract 15x from both sides, giving me 7 equals 8x minus 17. Then I'll add 17, giving me 24 equals 8x. Divide by 8, and we get that x is 3. Next up, we're looking at the vertex angle bisector theorem. So this says if a line bisects the vertex angle of an isosceles triangle, then that line is also the perpendicular bisector of the base. So here in the picture, we've got our sides marked as being congruent right here. So we have an isosceles triangle. Here is a line that we're going to say is bisecting the vertex angle. So it's cutting B in half. So then when that happens, then this line would also be a perpendicular bisector of the base. So the box tells me the perpendicular piece, and then the bisector is what those two congruent lines are, showing that each of these would have the same length. So here's our first example. We're asked to find the value of x. So I notice that I've got an isosceles triangle, which would mean that these base angles, so A and C, are both 54 degrees. So then angle B, all of angle B, we know would be what's left over from the 180 degrees. So if I take 54 plus 54, that gives me 108. And then 180 minus 108 is 72 degrees. So all of B would be 72 degrees, but x is just half of that. So we'll divide this by 2, and that gives us 36 degrees for x. Next up, we're going to look at some properties for equilateral triangles. If the triangle is equilateral, then it is also what we call equiangular. So equilateral means that all the sides are the same. And then equiangular would mean that all of the angles are the same. So here we have an example where we've got triangle ABC is an equilateral triangle. Find the missing sides and the missing angles. So the sides, since it's equilateral, are all the same. So 15, 15, and 15. Now the angles are also the same. So we know that if I added all three of these angles together, we would get 180 degrees. And if they're the same, I just need to divide the 180 degrees by the three angles we have. And that gives us 60 degrees for angles A, B, and C. Here's another example. Triangle PQR is equilateral. Solve for X and for Y. So if we take a look at the sides, we know that the sides are all the same. So I can set any two of these equal to each other and solve. So if I take 14y minus 59 and set that equal to 9y plus 1 and solve, so subtracting 9y on both sides gives me 5y minus 59 equals 1. Add 59. 5y equals 60. Divide by 5. And that gives me that y is 12. So if I would have paired two other ones together, so let's say I did 11y minus 23 equals 9y plus 1, I should also get 12. So subtracting 9y gives me 2y minus 23 equals 1. Adding 23 gives me 2y equals 24. Divide by 2, and you'll see again that y is 12. So I didn't have to do this twice, but just showing you could pair together any two of them and you would get the same thing. So then, dealing with x, notice that x is in the angle. If this is equilateral, all three of these angles are the same, and what we just found out from the previous slide is that 180 divided by 3 angles gives you 60 degrees for each of them. So angle R has to be 60 degrees, and that's also equal to 7x minus 3. So then we add 3, we get 63 equals 7x, divide by 7, and you get that x is 9.